So for our topic for today, we'll talk about the fluid mechanics. So in fluid mechanics, so we will focus on this topic is focused mainly in line or with connection to fluids. So when we say fluids, so what does it mean how or what are fluids? So ano ba itong fluid or um, how can we identify or what does it mean when we say fluid? So siguro, the first thing that comes to our mind when we say fluid is um, is liquid. So for just like the um, illustration, okay. So just like the illustration, so the first thing that would comes into our mind siguro when we say fluid are liquids, just like water, alcohol, or any other uh, liquids. And but fluid is not only limited, okay? Fluid is not only limited to liquid. Instead, fluid, okay? Fluid has is not only limited to liquid, but um, gases is also part of fluid. So gases and plasma are parts of fluid. So it is not only limited to liquid, but it also includes gases and plasma. Okay, so but what is fluid? What does it mean when we say fluid, and how can we know if it is a fluid? So when we say fluid, a fluid is any material that flows and takes the shape of the container. So it is any material that flows and takes the shape of the container. So that is fluid. So for example, in this illustration, so we have here a water that is being poured into the glass. So as the water is being poured into the glass, so the water will flow into the glass, and then um, since the glass is the container, so it will take the shape of the glass in which the water is being poured. And the same also with the kettle. So as the water will poured into the kettle, so the water will flow into the kettle and takes the shape of the kettle. And as the water is being heated, so if so as the water is being heated, as the water is being heated, then the the liquid or the water will evaporate. Okay, it will flow or it will evaporate from liquid or from water into a gas. And that gas, okay, so as the water will be evaporated from water into a gas, then the gas will take the shape of the kettle. So the gas will be contained inside the kettle and takes the shape of the kettle. And since the water is continuously evaporating, so it will come to a point where the kettle cannot contain the gas inside of it. That's why it will flow outside. So the gas will flow outside the kettle in a form of steam. So that is an example of fluids. So so I repeat, when we say fluids, so these are any materials that flows and take the shape of the container. So fluids has um, it has two different manners. So There are fluids who are at rest, okay, and there are also fluids that is in motion. So there are fluids at rest and there are also fluids in motion. So today we will focus on fluids that is in motion, that is it at rest. So we will focus on fluids at rest. So today we'll focus on fluids at rest, or in physics we call this as hydrostatics. Okay. So which is heavier? So I have here an illustration that will we need to compare which among them, or which among these two illustration is heavier. So we have here um, a nail and a boat, or uh, a nail and a boat. So which is heavier among the two? So I think we already know which among the two is heavier. So even a child can answer this clearly, that a boat is heavier than a piece of nail. So since a nail, okay, so since itong nail, ang kanyang timbang ay hindi aabot ng 1 kilo, and itong barko, so it has 1,000 of kilo. So thousands of kilo ang kanyang weight. So therefore, a boat is much heavier than a piece of nail. But, okay, so but why is it that a boat will float and a nail will sink? So bakit kaya yung boat ay will float and yung um, nail ay lumulubog? So bakit kaya siya ganon? So there are several reasons behind that. So there are several reasons kung bakit yung barko ay ay so yung barko ay it will float, and yung that piece of nail will sink. So one of that reason is because of density. So density, when we see density, so density is the measurement that compares the amount of matter an object has to its volume. So when we see density, it is a measurement, okay, a measurement that compares the amount of matter an object has to its volume. So what does it mean when we say amount of matter an object has? So when we say the amount of matter an object has, then in short, it is the mass of the object. So it is the mass of the object. So as we all know, okay, every matter has a mass. So every matter has a mass. So when we say amount of matter, okay, an amount of matter an object has, then we're talking about the mass of the object. So in short, you can say that the density is a measurement that compares the mass of an object to its volume. So it is a comparison between the mass of the object and its volume. So based on these three variables, which are density, the mass of the object, and its volume, so we can create, or we can have an equation based on these three variables. So density, we also have mass, and its volume. So based on these three variables, they created equation to for us to be able to identify the density of an object. So that equation is density is equal to mass of the object divided by the volume of the object. So its density is equal to its mass over its volume. And the symbol of density, okay, the symbol of density, it is not a small letter P, but it is a Greek letter, which is a rho, okay, a small letter rho, and mass is in grams, and volume is in cubic centimeter or in milliliter. So there are some or several units that is being used. Okay, there are several units that is being used for our density, but most of the time they are using grams over cubic centimeter or grams over milliliter. So sir, in our volume there are two units, cubic centimeter and milliliter. So saan ba dito ang dapat or which among the two is the most appropriate? So if you can still remember our topic on the in the conversation of unit, so based on the conversation of unit, based on the um, converting unit, so 1 cubic centimeter is equivalent to 1 milliliter. So therefore, 1 cubic centimeter is equivalent to 1 milliliter. So therefore, regardless of the two, they have the same um, they have the same magnitude. Okay, so the same lang ang 1 cubic centimeter and 1 milliliter since they are both equal. So depende. So they are the same. So the same lang si cubic centimeter and si milliliters. So in short, density is equal to mass over volume or mass divided by volume. So let's try to use this equation in a given problem. Okay, so we have here a sample problem. So what is the density of a 275 grams metal block having a dimension of 3.5 centimeters, 2.4 centimeters, and 3.7 centimeters? So in this case, we try to solve the density of the object, which is a metal block, okay, which is a metal block, which is a mass of 275 grams. So its mass is equal to 275 grams, okay? But for its volume, it is indirectly stated on the problem. What is the volume of the, what could be the volume of the metal block? But since the dimension of the block is given, which is 3.5 centimeter, 2.4 centimeters, and 3.7 centimeters. So using these dimensions, we can solve for its volume using the formula for volume. And in this case, since the object is a block, so as a block is part of rectangles, so we will use the formula for the volume of rectangle, which is equal to length times width times height. Using these dimensions, 3.5, 2.4, and 3.7. Okay, so let's try to solve its density using mass over volume. So since the mass is already given, which is 275 grams, and for our volume, so using the formula for volume, so length times width times height, so 3.5 times 2.4 times 3.7, that is equal to 31.08 cubic centimeters. So substitute your mass and your volume. Okay, so divide, and that is equal to 8.848133848 grams per cubic centimeters. Okay, and since the least number of significant figure we have is only two significant figure, so we will round this to two significant figure, and that is equal to 8.8 grams per cubic centimeters. And that is the density of the metal block. Okay? So another example. So kanina, we have a metal block. So this time, we'll try to solve the density of a metal cylinder. So if kanina, we use the formula for volume of rectangle since it is a block. Okay, so this time, since given yung mass, which is 250 grams, and the volume is unknown, so using the dimension of our object, which has a radius of 2.4 centimeter and a height of 5.1 centimeters, and with our object, which is a cylinder, so using the formula for the volume of cylinder, which is pi r squared h, or pi times the square of its radius times its height. So using that, we can solve for its volume. And using the volume and its mass, we can be able to solve for its density. So since the mass is already given, which is 250 grams, solve muna natin yung kanyang volume, which is using the formula for the volume of cylinder. So our radius is 2.4 centimeter and our height is 5.1 centimeters. So substitute. So volume is equal to radius, which is 2.4 centimeters square, times the height, which is 5.1 centimeters. So multiply, and that is equal to 92.28742579 cubic centimeters. So substitute your mass and your volume. So mass is 250 grams and volume is 92.28742579 cubic centimeters. So divide, that is equal to 2.7089288089 grams per cubic centimeters. And since the least number of significant figure we have is only 2, so round this to 2 significant figure. And the density of our metal cylinder is equal to 2.7 grams per cubic centimeter. So that is the density of our metal cylinder. Okay, so next for our last example, before we for our last example, so a person donates 1 unit of blood. So he donated a 1 unit of blood, which is equivalent to 450.0 milliliters. So the volume of the blood is 450.0 milliliters. How many grams of blood did he donated? So ilang grams daw ng blood ang kanyang na-donate. So since we are talking of grams, then we are dealing with the mass of the object. So if the calculated density of blood is equal to 1.05 grams per milliliter, so we can now be able to solve its mass using the density and its volume. Sir, saan ba nakuha si 1.05 grams per milliliter? Okay. So there are some objects. So may mga object which density has already been calculated by experts. So they already calculated the density of an object. So you can search it online. Okay, so pwede nyo siya ma-search online. Okay, and I will also give some of it. So some examples. So bigay ko na lang. So there are some objects that has already been calculated its density. So experts already calculated its density. And one example of it is the blood, which is equal to 1.05 grams per milliliter. So using the density and volume, we can be able to solve for its mass. So density is equal to mass divided by volume. So if density is equal to 1.05 grams per milliliter and volume is 450.0 milliliter, so substitute. So since mass yung unknown, we can multiply both sides. Okay, multiply both sides by 450.0 milliliters. So multiply both sides by 450.0 milliliters so that we can cancel 450. So maiwan na lang is meter as mass. And then for the left side, we have 1.05 grams per milliliter. So since we multiply it by 450, so ito na ang kanyang result. So cancel milliliter, then multiply 1.05 grams times 450.0, and that is equal to 472.5 grams. And since the least number of significant figure is only 3, so round this to 3 significant figure, and that is equal to 472 grams. And that is the mass of the blood which has been donated by the person. Okay, that is the mass of the blood which has been donated with, okay, pressure. So pressure. So when we say pressure, it is a force applied perpendicular to the surface of an object per unit area over which that force is being distributed. So when we say pressure, there is a force applied perpendicular to the surface of that object per unit area over which that force is distributed. So for example, in this case, yung finger, so when you point your finger on the wall, so if you point your finger on the wall, then you are applying force to the wall through your finger. And if you point your finger on the wall, you can observe that the wall, okay, the wall and your finger is perpendicular to one another. So that's why there is a force applied perpendicular to the surface of an object per unit area. So what does it mean when we say surface of an object per unit area? So balik tayo sa example kanina. So when you point your finger on the wall, okay, so when you point your finger on the wall, you are applying force which is perpendicular to that wall. And since you are applying force, okay, you are applying force, you are exerting pressure to that area where your finger is pointing. So you are applying pressure to that area where your finger is pointing. So that doesn't mean that na kahit pa you are pointing your finger on the wall, you are applying pressure to the entire wall. But you are only applying pressure to the area where that force is being distributed. So you are only applying pressure to the area where that force is being distributed. So in short, you are only applying pressure dun sa area where you are pointing your finger and not to the entire wall. So you are only applying force to the area where your force is being distributed. It is the same also with the syringe. So when a syringe is injected to your body, so the pressure is not being exerted to the whole body, but the syringe or the pressure of the syringe is being exerted to, to the area where um, to the to the area where you are being injected. So kung saan lang yung area na where you are injected, so then on that area is also the pressure is being exerted. So based on this variable, which are the pressure, force, and the area, so we can now have an equation based on these three variables. So from pressure, so pressure is equal to the force applied divided by the area being applied. So force applied divided by the area where it is being applied or the area where it is distributed. So pressure is equal to force divided by area, and that is the equation for pressure. Okay, so that is the equation for pressure, force divided by area. So let's try to use this equation. By the way, the unit for pressure is Pascal. Okay, the unit for pressure is Pascal with a symbol of P and A. And for our force, okay, the force is in Newton, and the area is in square meters. So the force is in Newton. Okay, yung force is in Newton, and the area is in square meters. So Pascal, which is the pressure or the unit of pressure, unit of force is in Newton, and the unit of area is square meters. So let's try to use this equation in a given problem. So the atmospheric pressure at sea level is 101,326 Pascal. So this is the atmospheric pressure. So ito yung pressure at the bottom of the sea. Okay, so this is the pressure at the bottom of the sea, which is equal to 101,326 Pascal. Assume that the approximate area of a person's head, so assuming there is a diver at the bottom of the sea, and the approximate area of that diver's head, which is perpendicular to the atmosphere, is equal to 450 square centimeters. So what is the force exerted to the diver by the Earth's atmosphere? So ano daw yung force that is being exerted? So in this case, we now have the value of our pressure, which is 101,326 Pascal. And we also have the value of our area, which is 450 square centimeter. And we are looking for the force. Okay. So using the equation for pressure, which is pressure is equal to force over area. Okay, so we will solve for the value of our force. So the pressure is equal to 101,326 Pascal. And for our area, which is equal to 450 square centimeters. Take note, the area is in centimeters. So we will convert this first into meter. So convert natin siya into meters. So 450 square centimeters to be converted into meters. So 450 square centimeter times 1 meter over 100 centimeter. And since our given is in square, so we also need to square our converting variables. So that's why it is 1 meter over 100 centimeter square. So 1 meter square, that is 1 meter square. 100 centimeter square, that is 10,000 square centimeters. So cancel yung square centimeters. So 450 times 1 divided by 10,000, that is equal to 0.045 square meters. Okay? So after converting your area into meters, so we can now substitute this in our given. So pressure is 101,326 Pascal is equal to force, which is the unknown, divided by area, which is 0.045 square meters. And that is equal to, so multiply both sides by 0.045 square meters. So makancel itong square meters. So maiwan na lang is si force, then 101,326 Pascal times 0.045 square meter. That is equal to 4,559.67 Newton. So since the least number of significant figure is only 2, so we will round this to 2 significant figure, and that is equal to 4,600 Newton. And that is the force that is being exerted to the diver. Okay? So that is the force that is being exerted to the diver. Okay? Do you have... Okay, so if we compare the pressure exerted by both of these species, so both the elephant and the lady, so we can see that the pressure exerted by the lady is much greater than the pressure exerted by the elephant. So bakit kaya mas malaki yung pressure ng lady, since mas mabigat naman or mas malaki yung force that is being exerted by the elephant? So the explanation of this is, as I have mentioned kanina, okay, so as I have mentioned kanina, the pressure that can be exerted by to the object is distributed to the area where it is being applied. So where the force is being applied, so yung pressure is madidistribute siya sa area. And since yung area that is covered by the elephant is much greater compared to the area that is being covered by the heel of the lady, so that is the reason kung bakit mas malaki yung pressure na na-exert ng lady compared to the elephant. Because the lesser the area, okay, the lesser the area is of an object, the greater its pressure. So kung mas maliit yung area, mas concentrated yung pressure na kanyang ma-exert. Unlike yung mas malaki yan area, then mas malawak yung madidistribute na area where the pressure is being exerted. So that's why mas malaki yung pressure na na-exert nung lady compared to the elephant. So, tutuloy natin ang ating discussion on pressure, but this time, pressure this time is not about applying force, but it is the pressure, okay? It is the pressure you feel once once a person or an object is on hydrostatic, or um, once a person is um, in the fluid. So once a person is on fluids, which fluids at rest, or we call this as uh, we call this as hydrostatic pressure. So hydrostatic pressure. So these are the pressure that we can feel once we are in the fluids. So for example, if you are in a swimming pool, or either you are in the sea, or if you happen to try riding an airplane or a helicopter, so the pressure you can feel once you are above, or you are in the atmosphere. So once you are above the ground, so the higher the height from the ground, then the greater the pressure you will also feel. And the same with for liquids. So for example, for if you happen to try scuba diving, so if you have tried scuba diving, so the deeper you go into the deeper you dive, then you can feel more pressure. So these are the hydrostatic pressure. So how can we solve, or how can we identify the value of hydrostatic pressure? So that is our topic for today. How to know, how to know hydrostatic pressure. How can we know the value of hydrostatic pressure? So by using this equation. So to be able to know pressure or hydrostatic pressure, so we will be using the density of the fluid, then multiplied by the acceleration due to gravity, and then we also multiply the height. Okay, height. So height is the yung sinasabi ko kanina, the depth, or yung kung ano yung height na na iyong sinisid while you are diving, or the um, the height of the airplane, or yung paglipad ng airplane once you are in the atmosphere. So that is the height. And since we talk about the pressure, so the unit that we are using in pressure, since we already know this last meeting, that the unit that we will be using in pressure is Pascal, and also the density. Okay, so the density is also since we also discussed this, that the density is in grams per cubic centimeter, or grams per per milliliters. And the gravity, so we already know what is the value of gravity, that is 9.81. And height, so since our density is in cubic centimeter or in milliliter, so our height, we will be using unit as in centimeters. So since we are using cubic centimeter in our density, we will also be using centimeters in our height. Okay, so let's try to to use this equation. Okay, so let's try to use this equation in a given problem or a given example. So we have here a swimming pool of width 90.0 centimeters, and its length is 240.0 centimeters, is filled with water to a depth of 70.0 centimeters. So calculate the pressure at the bottom of the pool due to the water above if the calculated density of the swimming pool is equal to 1000.0 grams per cubic centimeters. So in this case, we will try to identify the density. Okay, so we'll try to identify the pressure. Okay, the pressure you can feel once you are at the bottom of the pool if the calculated density of the swimming pool or the water in the swimming pool is 1000.0 grams per cubic centimeters. And so since and the dimensions of our swimming pool, so its width is 90.0 centimeters, its length is 240.0 centimeters, and its height or the depth of the swimming pool is 70.0 centimeters. So using the equation for pressure, which is pressure is equal to the density times gravity times height. So substitute our given that the density is 1000.0 grams per cubic centimeter. The value of our gravity is 9.81, and the height is equal to 70.0 centimeters. So substitute, then simplify. So 1000 times 9.81 times 70, that is equal to 686,700 Pascal. So since the least number of significant figure we have is only 3 significant figure, so the final answer is equal to 687,000 Pascal. And that is the pressure a person can feel once he is on the bottom of the swimming pool. Okay? So, for next example, at what depth will a diver experience a pressure of 210,375 Pascal? So if the density of seawater is approximately 1.024 grams per cubic centimeter. So we are, in this case, so this time, we are looking for the depth, okay, or the height, where the diver can experience the pressure of 210,375 Pascal. So approximately the density of seawater is equal to 1.024 grams per cubic centimeters. Okay. So if these are the given, so we have the pressure which is 210,375 Pascal, the density which is 1.024 grams per cubic centimeter, and we are looking for the value of our depth. Okay, we are looking for the value of the depth or yung height ng ng diver where he can experience that particular pressure. Okay, so using the equation for pressure, so pressure is equal to density times gravity times height. So substitute, our pressure is 210,375 Pascal. The density is 1.024 grams per cubic centimeters. And the value of our gravity is 9.81. Okay, so simplify 1.024 times 9.81, then that is equal to 10.04544. So since we are looking for the value of our height, so since yung height yung hinahanap natin, so ang gawin natin dito, we will divide both sides by 10.04544. Okay, so 210,375 Pascal divided by 10.04544. Then next is dito naman tayo sa kabila. So cancel, maiwan na lang is si height. Okay. Then next, we divide 210 by 10. Okay, 210,000 by 10. So that is equal to 20,942.33802. Okay, so that is the value of our height. So since the least number of significant figure we have is 4 significant figure based on our given, okay, from 210,375 and 1.024 grams per cubic centimeters. So since it is 4 significant figure, then we will round this to 4 significant figure, and that is equal to 20,940 centimeters. And that is the depth or the height where the diver can experience the pressure of 210,375 Pascal. Okay, so in hydraulics, okay, it is a change in pressure applied to an enclosed incompressible fluid is transmitted and diminished to every point of the fluid and to the walls of the container. So in the concepts of Pascal's principle or hydraulics, so it is the concepts in pressure, so yung pressure that is resulted in applying force. Okay, if you can still remember the pressure that is a result of applying force in a specific area. Okay, so that is the concepts for hydraulics. So you are applying force, okay, applying force into a specific area, okay, which results to the change in pressure of that enclosed which results to the change of pressure into that enclosed container. So there is a fluid, okay, merong fluid that is being placed, or there is a fluid that is placed in a closed container. So yung container, so yung lalagyan ay naka-enclosed, and then may fluid sa loob. Then you will apply pressure or force, okay, applying force into that container. Then since we apply force, then there is a change in pressure. So since there is a change in force, then there is also a change in pressure. So the change in force or the change in pressure into that container will be transmitted to the fluid. So it will be transmitted to the fluid, which will be also transmitted to every point of fluid and even to the wall of the container or yung lalagyan mismo. So because of the change in pressure, because of the applied force, so there is also a change in the pressure that can affect the fluid and even the container. So one example of this is we can say that one example of changing pressure in an enclosed container is a balloon. So I think all of us have seen a balloon. So nakakita naman siguro tayo ng balloon, a rubberized balloon. So um, inside the balloon, there is a fluid which is a gas. So once na you apply force into that balloon, okay, if you apply force into that balloon, so there is also since there is an change in force, so there is also a change in pressure into that balloon. And since you apply force, okay, since you apply force, then the the fluid inside the balloon, okay, the fluid inside the balloon is being affected, okay, it is being affected by the change in force or the change in pressure into that balloon. So ang mangyayari dito is since merong change in pressure or change in force, so therefore ang mangyayari is yung fluid inside the balloon or yung gas inside the balloon, okay, so it will be transmitted to every corner of the balloon. So since you apply force, so yung gas, it will be transmitted to every corner of the balloon. Doon sa corner na where hindi mo in-apply yung force. And since the balloon is rubberized, okay, so since rubberized yung balloon, so ang mangyayari sa balloon, so yung part na hindi mo inahawakan or yung part na hindi mo ina-applyan ng force, then dun matra-transmit yung mga fluid, okay, yung mga fluid. And since rubberized yung balloon, so ipupush ng fluid yung wall ng container, which is the rubber of the balloon. And since the fluid is pushing the wall, then since it is rubberized, and that is the reason kung bakit lumulobo yung balloon. So that is one example of Pascal's principle. But the most or the common application of Pascal's principle, which is hydraulics, is the hydraulic press. So hydraulic press, so this is the one example, one of the best example, or one of the best application in hydraulics or the Pascal's principle. So in a hydraulic press, so you can see this hydraulic press in some industrial field. So you can see this in some industrial field. So you can even see this in some motorcycle or car shop. So yung mga shop ng sasakyan or shop ng mga motorsiklo. So makikita mo itong hydraulic press. So in a hydraulic press, okay, so there are two there is a machine, which inside that machine is a fluid. So most of the time they are using oil as a fluid of that particular machine. And in that hydraulic press, okay, so there are two pistons in a hydraulic press, which is the piston A and piston B. So we will label this as piston A and piston B. So itong piston B, so siya yung ito yung piston where you will put your car or your motorcycle. So dito nila inilalagay ang sasakyan or yung motorsiklo. So for example, if may isang sasakyan dito sa taas, okay, no, naanala ninyo, sakyan na siya, bahala mo lagdili. Okay, so for example, if there is a car, so in the piston B, so in the larger piston, so dun nila inilalagay ang isang sasakyan or yung isang motorsiklo. And then in the piston A or in the smaller piston, okay, so ito yung nagpupush or ito yung nagpupush sa fluid, okay? So this serves as the input force, okay? This serves as the input force where force is being applied, okay, on the piston, okay? So tinutulak ang piston pababa. Okay, because of force, they are pushing the piston downward, so pababa. So if they are pushing the piston downward, then the fluid, okay, yung fluid, since tinutulak yung piston, so yung fluid is also being pushed by the piston. So yung fluid, as the piston goes lower or habang bumababa yung piston A, so yung fluid is also being pushed back. So tinutulak ng piston yung fluid. And since yung container or yung kanyang lalagyan ay masyadong matigas or masyadong makapal, so the fluid, okay, so the fluid cannot penetrate the wall of the container. So hindi niya, it cannot penetrate the walls. So ang gagawin ng fluid, so hahanap ito ng ibang daan. So since the only thing that that the fluid can penetrate is the piston B or the larger piston, so itutulak niya ang piston B, okay, tutulak niya pataas. So that is the reason kung bakit, okay, why does shops can lift motorcycle or cars. So the greater, kung mas malaki yung sasakyan, then it means mas mabigat rin yung isang sasakyan. So kung mas mabigat yung sasakyan, then it also requires much greater force on the input force or on the piston A. Okay, so kung mas malaki yung sasakyan, then it means mas mabigat rin yung sasakyan. So kapag mas mabigat yung sasakyan, then it also requires mas malaki na force that you need to place on the piston A or yung iyong input force. So this is an example of an application of Pascal's principle, which is the hydraulics. But paano ba natin malalaman? So paano natin malalaman or how can we determine the force needed, okay? Yung force needed on piston A or the input force needed to be able to lift a certain object, or how can we determine kung ano ba ang capacity na kayang i-lift na object using only the force that we apply on the input as our input force. So to do that, okay, we will use the equation or the knowledge we have on pressure, which is the pressure that we have discussed last time. Okay, so the pressure, which is a result of applying force into an area. So since merong area yung piston, and then merong force na inilalagay in that piston, so that's why there is a pressure on the smaller piston. And yung for the bigger piston naman, so since meron ding area yung bigger piston, and may force naman na inilalagay doon sa bigger piston, which is the force due to gravity that is equal to the weight of the object. And since piston A and piston B are on the same so since piston A and piston B are on the same instrument, so since they are on the same container and they use the same fluid, okay, so therefore, since they have the same fluid and they are also in the same container, so therefore the pressure on piston A and the pressure on piston B is equal. So the pressure on piston A and the pressure on piston B are equal. So they are equal. So since they are on the same container and they use the same fluid, so therefore their pressure is equal. So if equal yung pressure nila, then we can say that F over A, or the force on piston A, divided by the area of piston A, is equal to the pressure, which is also equal to the force on piston B and the area on piston B. And with that, so since they have equal pressure, and piston A and piston B has pressure, so therefore we can say that the equation that we can use to be able to identify the force or the area needed is equal to force of piston A divided by area of piston A is equal to the force on piston B divided by the area on piston B. So this will be the equation that we will be using in identifying variables in our hydraulic press. And take note, since we are using the pressure on that is a result of applying force into an area. So since in our past discussion, the pressure in this topic is in Pascal. So it is in Pascal. So the force is in Newton. And for the area, we use square meters. Okay, so the same with this topic. Okay, for the force on our force A and force B, we will also use Newton. And the area for A and area for B, we'll use square meters. So FA, we're in Newton, and area A, we're in square meters. And also FB, we're in Newton, and area B, we're in square meters. So this will be the equation that we will be using in hydraulic press. So let's try to use this equation in a given problem. Okay, so we have here, in a hydraulic lift, if a radius of the smaller piston is 5.0 centimeters, okay, so this is the radius of the smaller piston, and the larger piston is 50.0 centimeters, what weight can the larger piston support? Okay, so what weight can a larger piston support when a force of 250.0 Newton is applied to the smaller piston? So kung mag-apply ka daw ng 250 Newton dun sa mas maliit na piston, ano daw yung weight na kayang isupport ng ating larger piston? Okay, so since our pistons are on centimeters, so first we need to convert this into meters. So 5.0 centimeter to be converted into meters, that is equal to 0.05 meters. Okay, that is equal to 0.05 meters. And 50.0 centimeters, that is equal to 0.5 meters. Okay, so that is the conversion of the radius of our smaller piston and our larger piston. So since now we already converted our pistons or our radius, now we can be able to solve our weight, okay, using force of piston A divided by area of piston A is equal to force of piston B divided by area of piston B. So since we need the area and we only have the radius, so we need to solve for our area, okay, which is in square meters. So since our piston is circular, so since pa-circle siya or pabilog, then we will use the formula for the area of circle, which is equal to pi r square. Okay, so substituting our radius in meter, which is 0.5 for our smaller piston, then square, that is equal to 0.0025 pi, which is multiplied by pi. So this will be the area of our smaller piston. And for our larger piston, that is 0.5 square times pi, that is 0.25 pi square meters. Okay, so next, after we already have our areas, so we can now solve for the weight that the larger piston can support by using this equation. So substitute. Okay, so substitute. So our smaller piston is equal to 250 Newton. Then the area is 0.0025 pi square meters, is equal to the force on the larger piston, which is the unknown, divided by the area, which is 0.25 pi square meters. Okay, next, simplify. 250 divided by 0.0025 pi, that is 31,830.98862 Newton per square meters. So since yung hinahanap natin is si F sub B, so we will get rid of 0.25 pi by simply multiplying both sides by 0.25 pi. So multiply both sides by 0.25 pi para makancel ito. Then it will be transferred to the left side. Okay, so that's it. Okay, next, simplify. So cancel yung square meters. Then I multiplied the two values, that is equal to 25,000. And since the least number of significant figure is 2 and 25,000 is already two significant figure, so the answer is 25,000 Newton. Or, okay, so since we are looking for the weight, okay, so since ang hinahanap natin ay yung weight that the larger piston can support, then the weight is equal to 25,000 kilograms. So this is the weight that can support the larger piston. So ito yung maximum weight na kayang isupport ng larger piston, which is equal to 25,000 kilogram. Okay, so next example. A car weighing 1,250 kilogram is to be lifted using a hydraulic lift with 15.0 centimeters and 75.0 centimeters radii respectively. So yun yung mga radius ng ating mga pistons. So what input force can support the weight of the car? Okay, so ngayon, ang hinahanap naman natin ay yung input force na ating ilalagay sa ating piston A so that it can support the weight of the car, which is equal to 1,250 kilograms. Okay, so using the equation for hydraulics, but before that, we need to solve for our area, which is in meters. But our radius is in centimeters, so convert muna natin sila into meters. So 15.0 centimeters, that is equal to 0.15 meters, and 75.0 centimeters, that is equal to 0.75 meters. So this will serve as the radius of our pistons, which is piston A, that is equal to 0.15, which will be used as our radius for our area. So 0.15 square times pi, then that is equal to 0.0225 pi square meters. Then next, for our piston B, which has a radius of 0.75 meters, then square times pi, then that is equal to 0.5625 pi square meters. So after that, we can now solve for our hydraulics, or for the input force. Okay, so take note of the given on our force B. Okay, so force on our force sub B, since weight is equal to force due to gravity. So since yung weight is equal to the force due to gravity, and in our question, in our problem, it is specific in our problem, specifically stated that the car already has a weight of 1,250. So specific sa ating problem that 1,250 kilogram is the weight of the car. So sir, paano namin malalaman kung weight siya or mass? So if sa problem pa lang, okay, so sa problem pa lang, specific na sa problem na it is the weight of the car or weight of the object, or the object is weighing, so therefore we can assume that it is already the weight of the car. But since if in the problem, so in the problem, it is not specifically stated that it is the object is weighing, or the weight of the object. So hindi siya specifically stated. So therefore, we can assume that it is only the mass of the object. And if it is only the mass of the object, to be able to identify for the force due to gravity, so we need to convert it first into weight, which will be multiplied by 9.81. But since in this problem, it is specifically said that the car is weighing 1,250 kilogram, then therefore we can assume that it is already the weight of the car. And since weight is equal to force due to gravity, we can use this as our force in our piston B. So substitute, which is in Newton. Okay, next is simplify. 1,250 divided by 0.5625 pi, that is 707.3553026 Newton per square meter. And then we transpose, or we multiply both sides by 0.0025 to get rid of 0.025, para ang maiwan na lang is si F sub A. So lumipat na siya sa kabila. So now we can multiply. Okay, so cancel meter square or square meter. So the answer is 50. And since the least number of significant figure we have is 3, so since tatlo yung number of significant figure, and 50 only has one significant figure, so lagyan natin siya ng dot, then add 0. So 50.0 is now 3 significant figure. And so our final answer, or the input force that can support the weight of the car, is equal to 50.0 Newton. Okay, so that is the input force that can support the weight of the car.